Hello everyone, let's look at another problem which appeared in NET exam in June 2018. I went through a lot of questions which appeared in NET exam and I found out there are a number of problems that are based on various name reactions. This is one such problems. So I strongly encourage you to at least read 50 to 100 name reactions. There are thousands of reactions and I agree that you may not be able to remember all those reactions, but at least it is always handy to have those 50 to 100 name reactions in your head all the time. Okay, now let's look at how to approach this particular reaction. Okay, so the first step of this reaction is a Shapiro reaction which involves the treatment of hydrazones with two equivalents of butyl lithium followed by treatment with formaldehyde. Okay, the speciality of Shapiro reaction is that when aldehydes or ketones, okay, when we make their hydrazones, when they are treated with a strong base, in fact two equivalent of it, then we end up getting alkenes, and this reaction favors the formation of least substituted olefin. Okay, now let's start this problem. So since we are going to use the two equivalents of butyl lithium, so we are using two equivalents. One equivalent will be used to abstract this hydrogen which is on nitrogen, and the other abstracts this hydrogen. Generally bases like butyl lithium and aldehyde, they encourage the formation of kinetically controlled product. And the second thing is that in the Shapiro reaction, the least substituted olefin can only be obtained if this hydrogen is abstracted. Okay, now we end up getting the anionic species. So now the negative charge comes here and the tosyl group leaves. Okay, minus tosyl. So the next step is the expulsion of nitrogen from the reaction. Okay, so now in the case of Shapiro reaction, this intermediate gets quenched with water to give alkene as major product. This happens in case of Shapiro reaction. But here the question that is asked to us, here they have added formaldehyde into the reaction. So what happens when you add formaldehyde? This negative charge will attack the carbonyl group of formaldehyde, and on quenching it will give this alcohol as the major product. So this is compound A. So this is one part of the problem which is on the name reaction, which is called Shapiro reaction. Now let's look at the second part of the problem, which is the orthoester Johnson-Claisen rearrangement, how this compound when treated with trimethoxy orthoacetate undergoes Johnson-Claisen rearrangement. Okay, so we have this triethoxy orthoacetate which gets protonated. Since we have this propanoic acid which is in catalytic quantity, this gets protonated to form OH. This leaves. So we have this activated species. Now what happens here now? Compound A, which is alcohol, it attacks the species, okay, and it leads to the formation of course minus H plus C OET, OET, methyl. Okay, and next step is this comes back and this leaves as ethoxide ion. Now the ethoxide ion which has been expelled from the reaction, it acts as a base to abstract this hydrogen. This comes back here and this positive charge is then released. Now the molecule is perfectly set to undergo Johnson-Claisen rearrangement. So this compound undergoes smooth 3,3 sigmatropic rearrangement. Okay, so what happens, this comes back, comes here, this comes here, and this bond moves. Since 3 atoms are involved in each side, since this bond is getting break, and we have 1 2 3 atom, and since this involves the movement of sigma bond, that is why we have this sigmatopic rearrangement. So the product that we get is which is compound B. Okay, so that is how we need to counter these sort of problems, and it is very important to memorize a number of named reactions. It is only going to make your work much more easier. Okay, thanks a lot for watching the video, and if you want me to cover any special topics, then do send me an email on unlockchemistry@gmail.com. Thank you very much.